All right, welcome. This is the narrated PowerPoint for actually chapters 2 and 3 in Unit 1, Chemistry and Cells. I'm going to take you rather quickly through these, and you will be able to review as much as you need and also watch these unnarrated, non-narrated as well will be available to you. Again, much of this is available in your textbook, pretty much all of it, so there will be plenty of review. Not going to spend too much time on chemistry, but hit the highlights. We look at chemistry to help us understand the composition of matter. Matter is anything that occupies space and has mass. Mass is not the same as weight. Mass is basically how much space we take up. Weight is mass times gravity. We will weigh less on the moon, for example, because there is less gravitational force on the moon. And matter can be in a solid, liquid, or gaseous state. Weight, as I said, is a gravitational force. Here's a periodic table I've included for you. This is just a very abbreviated periodic table. I don't believe you have one in your textbook. This just shows you the atomic numbers of each element. You don't have to memorize this, but I thought it would be interesting for you to have it if you want to just take a look at it. All right, we need to look at atoms and subatomic particles. You will need to understand that a proton has a positive charge and it's located inside the nucleus. You will need to know what an electron is and a neutron. We're not really going to study reactions between atoms and or molecules, but I do want you to know some basic definitions: the atomic number and the mass number. So those are written here for you. I don't need to read all of this to you. A molecule is formed of two or more atoms that chemically combine. Here's an example. A compound is a chemical combination of two or more different types of atoms. NaCl is sodium chloride, which is common table salt. Now we're already into chapter 3, which are cells. In chapter 2, let me just go back a bit. You will need to understand what atomic number and atomic mass is. So be sure that you do have those concepts clear in your mind, and what constitutes what is meant by atomic number and what is meant by atomic mass. Here are the functions of the cell and the introductory PowerPoint that I did for you. It said the basic functions or characteristics of life. Since a cell is the basic unit of life, it does in fact have all of the characteristics of life. It can synthesize molecules, it can communicate, it can carry out metabolism, it can reproduce. It also contains some subcellular structures, which we call organelles, which literally means little organs, and cytoplasm, which is the internal material of the cell. A cell membrane is the outermost component of the cell. It is a dynamic structure. It's not just an envelope that holds the cell contents in place. It is a dynamic structure, and we will take a little faster, further look at it. Notice some of the functions. Definitions referring to cells. Extracellular means outside of the cell or exterior to the cell membrane. Intracellular means interior to the cell or interior of the cell membrane. Here is the structure of the cell membrane listed for you. It is called fluid mosaic because it is a dynamic, somewhat fluidy structure, and it looks somewhat like a mosaic in that it is not a homogeneous structure. Here are the components, and I'm going to show you a diagram. This is one of the subunits of a cell membrane that contains a polar head. Polar means that it is hydrophilic. In other words, it likes water. It will be in contact with water. The nonpolar portions of the phospholipid membrane component of the cell are hydrophobic, literally fearing water. They will not be found in contact with water. And this is very important for the structure of the cell membrane, because you will find that the structure of the cell membrane is such that these hydrophilic, water-loving portions of the cell membrane will be found in contact with the exterior fluid of the cells and the interior of the cell, and the hydrophobic structures or tails will be the internal bilayer of the cell membrane itself. If you put these types of molecules, these phospholipid molecules, in water, they will self-associate and kind of form a membranous structure. Then interspersed throughout the cell membrane are receptor molecules which help the cell to recognize and respond, channels which help materials pass through, and various carbohydrates, cholesterol molecules that are important for cell function. Movement through a cell membrane will selectively determine what moves in and out. Enzymes, glycogen, which is formed of glucose molecules, and potassium are generally found in higher concentrations inside the cell. Sodium, calcium chloride are found in higher concentrations outside of the cell. We're not going to belabor that point too much, but it is very important in terms of nerve impulse transmission and muscle impulse transmission, so we will come back to that. Molecules can pass through a cell either directly by diffusion. Small molecules such as oxygen and carbon dioxide will diffuse through the cell membrane. Some molecules pass via membrane channels. These channels are formed of proteins, and for example, sodium will pass directly through membrane channels. You will need to review this in your text. Here is an example. Small molecules that are lipid soluble will diffuse directly into the cell, as will other small molecules such as sodium and potassium. And others will diffuse through the membrane channels depending upon their concentration gradient, and that will become clearer in just a moment. Carrier molecules can help transport items into or out of the cells. Vesicles will fuse with the cell membrane and allow materials to pass either into the cell or out of, depending upon the direction they need to move according to the cell's needs. Here is another example of how glucose is transported. I'm going to move quickly through that. I'm not going to really belabor that. Here's something interesting, a secretory vesicle. So this is for materials being moved out of the cell or excreted from the cell. Will collect into a secretory vesicle and then will literally fuse with the cell membrane and move out of the cell. This is an example of what we call exocytosis. Let's get back to diffusion. Movement of molecules from areas of high to low concentration. These are some definitions you will need to know. A solution is a solid, liquid, or gas that contains one or more solutes. A solute is a substance added to a solvent that dissolves, and a solvent is a substance, generally or often water, which is called the universal solvent, that is being used to add solutes to. Review these definitions. Here is an example of diffusion where molecules will move from an area of their own higher concentration to an area of their own lower concentration. These visuals that are in your book are very good for you to look at. This shows you an example of salt crystals, or this could be sugar cube placed in a solution or in water, will diffuse till they are spread equally throughout All right, a concentration gradient measures a difference in concentration, and filtration is defined here for you. I have about 5 more minutes to go through these, so I'm going to move quickly. I want you to review. We're not going to spend too much on mediated transport. Just know what this means. Facilitated means being helped. Active transport means energy is actually used to move certain substances from an area of their own low to an area of their own high concentration. Here are some examples. Facilitated diffusion using carriers, but going with the concentration gradient. Active transport going against, we could say, the concentration gradient. Osmosis is the diffusion of water. And this is important for you to know the different types of osmotic solutions. Hypotonic, I have some homework and forms that will help you to solidify these concepts in your mind. So please review hypotonic, hypertonic, and isotonic. And here are some examples of what will happen to a red blood cell when it is placed in a solution that it is hypotonic, or of lower concentration of solids to the red blood cell. It will swell and possibly burst or lyse. We want red blood cells in an isotonic solution. This is what happens. They shrivel in a hypertonic solution. Make sure that you know this. Our homework this week also has some questions to help you. Endocytosis means moving things into the cell. There are 2 types, phagocytosis and pinocytosis, cell eating and cell drinking. Here are some visuals to help you with that. Exocytosis, moving things out of the cell. We looked at that before for excretion. And here is another more, let's say, close example of that. This is a generalized diagram of the cell. I have some questions about the cell on your homework. Here's just an overview of cell structure. Please read and review this. Some electron micrographs showing you what these would look like under the electron microscope. Again, some of the cell structures for you to learn, which you can certainly read about and look at on your own. We're not going to spend time on heredity or cell division really, but this tells you some of the hereditary material and what it does. An example of a human or any animal's chromosome, showing you the double helical structure of that molecule. And here are some other structures in the cell membrane, the nucleolus. And here's an example or definition of what ribosomes are and where they are located. And again, showing you some of these cell structures. Smooth endoplasmic reticulum, look up its function, and rough endoplasmic reticulum, which has ribosomes attached. These are, again, things that you can read and look at for examples and what these structures look like and what their functions are and what lysosomes do. And this is the mitochondria, which is a very interesting cellular organelle involved in metabolic processes for the cell. And cilia and flagella, we will come back to looking at cilia. They cover cell surfaces, especially in the respiratory and digestive tract, particularly the respiratory tract. Flagella, for example, are found on sperm cells, and microvilli are very important in the digestive system. So we will get back to these structures as we proceed through the term. And cytoskeleton, here is an example of the definition of cytoskeleton. What it is, it forms the cell's framework within the cytoplasm, various fibrous kinds of molecules. And we'll just end with a structure of DNA, although again, we're not going to belabor this. This is what I wanted to emphasize for you. Please have a successful Unit 1. Message to me, do the forms, do the homework, and I will chat with you soon.